Welcome back to Geometry. Chapter 5, Section 1 in this book, Perpendiculars and Bisectors. So, if a line is perpendicular, it makes the upside down letter T, or the right side up. It just means that there are right angles, and if this line continued, there'd be 4 right angles. That's what perpendicular is, and the symbol for it is just a little upside down T like that if you want to show something to be perpendicular. Now, there's a perpendicular bisector theorem. So what does bisector mean? Bi means to, sect means cut in half. So if we take this line and cut it in half, then it has been bisected. Cut in half, bisected. So if you have lines that are perpendicular and this line is bisecting that line, I guess we need not arrows here. There we go. Then that would mean that these two would be equal. So the perpendicular, okay, so that's the first idea. The second idea is the perpendicular bisector theorem, which is if you have a point on the perpendicular bisector, that's what that is, and then it is equal distance to points on the line. So that means that this point is the same distance from this point to that point and that point to that point. So if this is like point A and that one's B and that one's C, C is equidistance, meaning the same distance between A as it is from A to B. Now these two are the same and those two would be the same. And this line equals itself, so these two triangles would be equal. Do you see that? Okay, so the converse is, if you have a point that is equidistance from points that are on a line like this, then it is a perpendicular bisector. That it's not going off at some weird angle or anything like that. It's right, nice, perpendicular, and it is bisecting the line segment. Okay? Now, here is a way to use it. Here we have this line that is perpendicularly bisecting line TS right in the middle there at N. We know it's a perpendicular bisector because it's got the right angle sign, and these two are the same. The one red line means these two are the same. So that means like point M would be equal, this line MT would be equal to line MS because they are a point that is on a perpendicular bisector. These two are equal, so that means these two have to be equal by the perpendicular bisector theorem. Okay? So what else would be equal? Those are equal. Another thing is, what if you continued this line, would Q be on it? Well, we're told that this distance is 12 and this distance is 12, so that line equals that line. And if we continue this line on out to Q, it would be on it because these two are the same. It's the perpendicular bisector converse that these two are the same. So this point is on the perpendicular bisector, and this is perpendicular. So the point's on it. We know that that it is on MN, on line segment N. Just put a little line over. All right. So there's the perpendicular bisector theorem for lines. We can also have the angle bisector. This is an angle. We can have a line go in exactly in the middle so that this angle is equal to that angle. Okay, that's the bisector theorem, that if you have a point on an angle bisector and these two lines are equal from A to C and A to B, then we can draw a line from D to B and from C to B, and those lines would also be the same. They would be equidistance because it's a bisector, just like that point is equidistance because it's a bisector. And then the converse, if these things are all equal, then you know the line does bisect it because this point is equidistance from B and C. So read those in your book, study the examples, make sure you understand them. But it's just logical. If this thing is cut in half, then this point would be equidistant from it. If this thing is cut in half, that point would be equidistant from the sides. It's just kind of logical, right? All right, so I think that was fun. See you next time. We'll come back and talk about the next section. Math is great. See ya.